what we're going to do is we're going to review the concept of mole and the mole calculations that we've been doing in class, or at least some of them. Now remember, the mole is just a term that refers to a specific number of entities, which is Avogadro's number of entities, 6.022 times 10 to the 23. And with our mole, we also have the idea of the molar mass, which is the mass of 1 mole of a substance. And we talked about in class how we calculate this, right? And so, for example, if we're going to determine the molar mass of our sodium hydrogen carbonate, what we have to do is we have to take into account the molar mass of each element and the number of times that they occur in 1 mole of sodium hydrogen carbonate. So here we have our calculations, where we take the molar mass of sodium. We have 1 mole of sodium in sodium hydrogen carbonate. We take the molar mass of hydrogen. We have 1 mole of hydrogen and 1 mole of sodium hydrogen carbonate. Take the molar mass of carbon. And finally take the molar mass of oxygen, and in this case now we have 3 moles of oxygen. And the way we know that we have 3 is the subscript on the oxygen is a 3. So therefore for every 1 NaHCO3 we get 3 oxygen, and that's where we get that. So we multiply it out, and then we add the masses together, and we get our molar mass of our sodium hydrogen carbonate of 84.01 grams per mole. Now, with our calculations, we have a number of values and a number of units. Okay, and so we have our mass, we have volume, we have moles, we have molecules, we have our molar mass, and we have our Avogadro's number. And in this table you can see the symbol for each of these variables in our calculations, as well as the name of the unit and also the unit. Okay, now, when we do our calculations, we're going to be looking at going between our mass, the number of moles in a given mass, or the number of particles in a given mass. And so we know that we have a relationship between all of these, and we know that we can go between our mass or our moles, and to do this we use our molar mass. And we know that we can go between our moles and our particles, and to do this we use Avogadro's number. Now, if I'm going to go from between mass and moles, we use our molar mass. And to go from mass to moles, we divide by molar mass, or we can multiply by the inverse. Or to go from moles, we multiply by molar mass. Likewise, to go from moles to number of particles, we multiply by Avogadro's number. Or to go from number of particles to moles, we divide by Avogadro's number or multiply by the inverse. From this, what we can see is to go from moles to one of our other ways of representing the amount of particles or matter I have, I multiply. To go into moles for either of them, we divide or multiply by the inverse. So, for example, let's say we want to determine the number of moles in 15.68 grams of sodium chloride. As we can see in our little sketch up in the corner showing us our roadmap, we're starting off with mass, and we want to go to in red, and we want to go to moles in blue. And so we're going through one variable, so therefore we only need one conversion, and I'm going to multiply by the inverse of my molar mass. So first thing we do, we write down our givens, and we can see, hey, we need to know our molar mass of sodium chloride. So we do our calculation to get it. Okay, and then we can record it in our givens. And then we look at what our equation is. And we know that our moles is equal to my mass, my starting point, multiplied by the inverse of the molar mass. And so when we substitute in with our units, we can see that our units cancel out, and we're left with the unit of interest. The final thing we want to do is make sure that we have correct sig figs. Okay. If we are given a number of particles and we're asked to determine mass of that number of particles, now we can see we start again off at particles in red. We want to go to mass in blue. So to do that, I have to go through moles. And so therefore, to go from particles to moles, I multiply by the inverse of Avogadro's number. And then to go from moles to mass, I multiply by molar mass. So we write down our givens. We know that our number of particles, that's going to be our starting point. We need Avogadro's number to get into moles, and that's a constant. And then we need our molar mass to get to our mass, so we would calculate that on the side. And then we can write out our equation. So my mass, which is my target, is equal to my number of particles, my starting point, times the inverse of Avogadro's number, that gives me the moles, times my molar mass, which gives me my mass. So we can substitute our values in. We can see we start off with our number of particles. We multiply by the inverse of Avogadro's number. Number of particles cancels out, leaving with moles. And then I multiply by my molar mass, which cancels the moles out, leaving me with mass.